Welcome to AI Frontiers, where we explore cutting-edge research at the intersection of artificial intelligence, language, and cognitive science. In today's episode, we'll be examining recent advances in computational linguistics and natural language processing that are reshaping how machines understand and generate human language. This field has experienced tremendous growth in recent years, driven largely by the development of increasingly sophisticated large language models. These models have revolutionized approaches to language processing tasks and opened new possibilities for AI applications across numerous domains. Join us as we dive into the latest research findings, methodologies, and future directions in this rapidly evolving field. Computational linguistics sits at the intersection of artificial intelligence, computer science, and linguistics. This interdisciplinary field focuses on developing theoretical and applied computational techniques for modeling and processing human language. The significance of computational linguistics extends far beyond academic research. It underpins many technologies we interact with daily, from voice assistants and machine translation to content recommendation systems and search engines. Recent growth in the field has been primarily driven by increasingly sophisticated large language models, or LLMs. These models have transformed how researchers approach language processing challenges and expanded the possibilities for practical applications. Computational linguistics also contributes to fundamental AI research by addressing one of humanity's most complex cognitive capabilities, language. Current research in this domain spans both theoretical advances that deepen our understanding of language and practical applications that bring these insights to real-world problems. The diversity of approaches reflects the multifaceted nature of language itself and the varied challenges involved in teaching machines to process it effectively. The first major research theme emerging from recent computational linguistics work involves enhancing reasoning capabilities in large language models. Researchers are focusing on improving how these models think through complex problems, with chain-of-thought prompting emerging as a powerful technique. This approach encourages step-by-step thinking processes in language models by prompting them to generate intermediate reasoning steps before producing a final answer, often leading to more accurate results on complex reasoning tasks. Xu and colleagues have introduced SoftCoT++, which extends chain-of-thought reasoning into the continuous latent space of language models rather than limiting it to discrete token generation. Their method enables diverse exploration of reasoning paths and demonstrates significant improvements over traditional approaches across multiple reasoning benchmarks. However, Li and colleagues have revealed an important limitation of chain-of-thought prompting. In their work, When Thinking Fails, they demonstrate that explicit reasoning can sometimes harm instruction-following performance by diverting attention away from crucial constraints. This counterintuitive finding highlights that reasoning is not universally beneficial and that models may need mechanisms to selectively apply different thinking strategies depending on the task at hand. Addressing this challenge, Tu and colleagues developed AutoThink, a multi-stage reinforcement learning framework that teaches language models when to engage in explicit reasoning based on problem complexity. This approach addresses the overthinking problem, where models generate detailed reasoning steps even for simple problems, leading to computational inefficiency. A key challenge in this research area remains finding the optimal balance between reasoning depth and computational efficiency. The second major research theme focuses on Retrieval-Augmented Generation, commonly known as RAG. This approach combines the generative capabilities of language models with the ability to retrieve and incorporate external information. RAG has become increasingly important as researchers work to ground language model outputs in factual information, reducing hallucinations and improving accuracy. Xi and colleagues have introduced AutoRefine, a framework implementing a search and refine during think paradigm. This allows models to iteratively filter and organize evidence between successive search calls. The core innovation lies in introducing explicit knowledge refinement steps between search operations, enabling the model to distill and organize information more effectively before generating an answer. Addressing computational efficiency concerns, Couturier and colleagues proposed semantic caching of contextual summaries for efficient question answering. Their approach stores and reuses intermediate contextual summaries to reduce redundant computations by up to 50 to 60% while maintaining answer accuracy comparable to full document processing. This represents an important advance in making retrieval-augmented generation more computationally efficient. Li and colleagues tackled another challenge in retrieval-augmented generation: hallucinations caused by irrelevant retrieved content. They fine-tuned language models to resist generating false information when provided with irrelevant retrieved content, making RAG systems more robust and reliable. Current research in this area focuses on reducing hallucinations while maintaining computational efficiency, a balance crucial for practical applications. The third major research theme explores cross-lingual transfer and multilingual capabilities. As language technologies expand globally, researchers are developing methods to transfer knowledge from resource-rich languages like English to less represented languages. Li and colleagues introduced semantic-aware linear transfer, or SALT, which recycles embeddings from pre-trained language models to enhance cross-lingual transfer. Traditional approaches to cross-lingual transfer often constrain the expressive capacity of models in the target language because the source model is predominantly trained on English data. SALT addresses this limitation by deriving unique regression lines based on vocabulary similarity, enabling more effective handling of non-overlapping tokens. Chang and colleagues addressed the challenges of translating low-resource minority languages, specifically focusing on Hakka. They combined large language models with retrieval-augmented generation to preserve cultural nuances in translation. Their approach demonstrates how advanced language technologies can be adapted to serve linguistic communities that have historically been underrepresented in natural language processing research. In a similar vein, Phan Tran Minh Dat and colleagues focused on cultural and linguistic preservation efforts through Bahnaric Vietnamese translation. They developed translation systems for low-resource languages using transfer learning approaches, starting with a pre-trained Vietnamese language model and continuing training with limited bilingual resources. This research achieved effective translation despite the scarcity of Bahnaric data. A significant challenge in this area remains maintaining cultural context and linguistic nuance when transferring between languages with different structures and cultural backgrounds. The fourth major research theme addresses efficient resource utilization. As language models grow larger, their computational demands become increasingly significant. Researchers are proposing methods to reduce memory usage and increase processing speed without sacrificing performance. Su and colleagues presented a technique for accurate KV cache quantization by identifying and handling outlier tokens. Their key insight is that a small subset of tokens exhibits unique characteristics that deviate from expected patterns, significantly impacting quantization accuracy. By developing a method to identify these outlier tokens during the decoding process and exclude them from quantization, they achieved a 6.4 times reduction in memory usage and a 2.3 times increase in throughput. This finding is particularly important as it addresses one of the main bottlenecks in deploying large language models in resource-constrained environments. Sun and colleagues addressed the challenge of efficiently handling long contexts in their work, Solopo. Unlocking long context capabilities in LLMs via short-to-long preference optimization. Their approach decouples long context preference optimization into two components: short context preference optimization and short-to-long reward alignment. This enables more efficient training while improving the model's ability to handle extended contexts, an important advance for processing lengthy documents or multi-turn conversations. Huang and colleagues developed history-aware policy optimization, HAPO, which reduces solution length by 33 to 59% with only minimal accuracy losses of 2 to 5%. This focus on efficient resource utilization is critical for deployment in resource-constrained environments and becomes increasingly important as models continue to expand in size and complexity. Several breakthrough insights have emerged across recent computational linguistics research papers. Chang and colleagues demonstrated that the simple BLEU metric, typically used for machine translation evaluation, can match complex reward models for language model alignment. Their approach, called BLEUBERI, achieved competitive results compared to models trained with sophisticated reward models across 4 challenging instruction-following benchmarks. This finding suggests that given high-quality reference outputs, simple metrics can serve as effective proxies for expensive reward models during alignment, potentially reducing the cost and complexity of aligning language models with human preferences. Lee and colleagues discovered that explicit reasoning can harm instruction following by diverting attention from constraints. Their evaluation of 15 different models found consistent performance degradation when models were prompted to reason through instruction following tasks. Their analysis revealed that reasoning can divert a model's attention away from crucial constraints in the instructions, leading to outputs that failed to meet specified requirements. Wei and colleagues achieved a remarkable 1.47 times speedup over the industry's standard GCC03 compiler in assembly code optimization using language models with reinforcement learning. This demonstrates the potential for AI to improve software performance in highly specialized technical domains. Zhang and colleagues found that while large language models understand ontological knowledge, they struggle significantly with ontological reasoning and learning tasks. This highlights a fundamental limitation in current language models' ability to work with structured knowledge representations. Thompson and colleagues developed time-aware fine-tuning approaches that improve early risk detection for mental health monitoring, demonstrating the potential real-world impact of computational linguistics research on critical health applications. Several common methodological approaches are driving progress in computational linguistics. Reinforcement learning from human feedback, or RLHF, has become a cornerstone methodology for aligning language models with human preferences. This approach involves training a reward model on human preference data, then using reinforcement learning techniques to fine-tune language models based on this reward signal. Chain of thought and advanced prompting techniques enhance reasoning capabilities by encouraging step-by-step thinking processes. These approaches can significantly improve performance on complex reasoning tasks and make model outputs more interpretable, though they are not universally beneficial. Retrieval-Augmented Generation grounds language model outputs in factual information by retrieving and incorporating external knowledge. This reduces hallucinations and improves accuracy, though its effectiveness depends heavily on the quality of retrieval. Parameter-efficient fine-tuning methods, such as low-rank adaptation or LoRA, allow researchers to adapt large models with relatively few trainable parameters. This makes it feasible to create specialized versions of large language models without the computational expense of full fine-tuning. Multimodal integration approaches combine text with other data types such as images, speech, and video. As language models expand beyond text, researchers are developing innovative techniques for integrating different types of information effectively. These methodological approaches represent current best practices and innovative techniques that are collectively advancing the state-of-the-art in language processing technologies. Let's examine one of the most interesting recent papers in computational linguistics, BLEUBERI by Chang and colleagues. The full title is, Blueberry. Blue is a surprisingly effective reward for instruction following. This work presents a key innovation, using the simple BLEU metric, traditionally employed for evaluating machine translation quality, as a reward function for language model alignment. BLEU essentially measures the overlap of n-grams between a model's output and reference text. The researchers' approach involves identifying challenging instructions and then applying group relative policy optimization using BLEU directly as the reward function. What makes this research particularly noteworthy is that it achieved competitive results compared to models trained with complex reward models across 4 challenging instruction-following benchmarks. The significance of this finding cannot be overstated. It suggests that given high-quality reference outputs, simple metrics can serve as cheap yet effective proxies for expensive reward models during alignment. This could dramatically reduce the cost and complexity of aligning language models with human preferences, making advanced AI development more accessible. This paper was selected for discussion because its counterintuitive finding challenges established approaches to language model alignment, which have typically relied on increasingly sophisticated reward modeling techniques. Another groundbreaking paper worth examining is When Thinking Fails by Lee and colleagues. This research evaluated 15 different models on instruction-following tasks with reasoning prompts and found consistent performance degradation when models were prompted to reason through these tasks. This finding directly challenges the increasingly common practice of applying chain-of-thought prompting indiscriminately across different types of tasks. The researchers' analysis revealed that reasoning diverts a model's attention away from crucial constraints in the instructions, leading to outputs that failed to meet specified requirements. This phenomenon was observed across models of different sizes and architectures, suggesting it's a fundamental limitation of current approaches to reasoning in language models. What makes this research particularly valuable is its practical solution. The authors proposed a classifier-based approach to selectively apply reasoning only when beneficial. This approach first determines whether reasoning would help or harm performance on a given task, then applies reasoning selectively based on this determination. The implications are significant for developing more nuanced prompting strategies that can adapt to different task types. This research was selected for discussion because it challenges a widely adopted practice in the field and offers concrete evidence that more sophisticated approaches to model reasoning are needed. The research on history-aware policy optimization, HAPO, by Huang and colleagues represents another significant advance in computational linguistics. This novel approach incentivizes language models to find increasingly concise reasoning solutions while maintaining accuracy. The key mechanism involves tracking the minimum length of previously correct responses for each problem and using this information to encourage the model to generate even shorter correct solutions over time. When tested with various 1.5 billion parameter models, HAPO achieved remarkable length reductions of 33 to 59% with only minimal accuracy drops of 2 to 5% across several mathematical reasoning benchmarks. This represents a significant advance in making language models more efficient at inference time without substantially sacrificing performance. The approach is particularly valuable because it addresses a common inefficiency in language models: their tendency to generate unnecessarily verbose solutions even after they've understood how to solve a problem. By encouraging models to distill their reasoning to its essential components, HAPO can significantly reduce the computational resources required during inference. This research was selected for its practical impact on deploying models in resource-constrained environments, where efficient use of computational resources is crucial. It demonstrates how reinforcement learning techniques can be applied not just to improve accuracy but also to optimize the efficiency of language model outputs. Based on current research trends, several promising future directions are emerging in computational linguistics. First, researchers are likely to develop more nuanced approaches to model reasoning based on task characteristics. Rather than applying chain-of-thought prompting universally, future systems may intelligently determine when and how to apply different reasoning strategies based on the specific requirements of each task. Second, bridging the gap between ontological understanding and reasoning capabilities represents an important frontier. While current language models show proficiency in understanding ontological knowledge, they struggle with reasoning and learning tasks involving structured knowledge representations. Addressing this limitation could lead to more robust AI systems that better integrate with formal knowledge bases. Third, creating more efficient retrieval-augmented generation systems with better filtering of irrelevant information will be crucial. As RAG approaches become more widely adopted, improving their ability to identify and focus on truly relevant information will enhance both efficiency and accuracy. Fourth, expanding language technologies to underrepresented languages with cultural preservation in mind represents both a technical challenge and an ethical imperative. As language technologies become increasingly central to information access and communication, ensuring equitable access across languages and cultures grows in importance. Finally, integrating multimodal capabilities while maintaining computational efficiency will be essential as language models expand beyond text to incorporate other data types. The challenge will be to develop architectures that can effectively process and integrate multiple modalities without excessive computational demands. This research synthesis was created using AI tools including GPT Anthropic using model Claude 3-7 Sonnet 20250219. The process involved analyzing recent research papers in computational linguistics, identifying key themes and findings, and synthesizing this information into a coherent narrative. Text-to-speech synthesis was performed using Google technologies to convert the written content into spoken narration. Visual elements accompanying this podcast were generated using Google image generation capabilities, designed to illustrate key concepts discussed in the presentation. All content underwent review by a human expert for accuracy and coherence to ensure that the technical information was presented correctly and in a manner accessible to the intended audience. While this content has been thoroughly reviewed, Some oversights may exist. All references to original research papers are provided to enable listeners to explore topics of interest in greater depth. This methodology combines the analytical capabilities of AI with human expertise to deliver comprehensive and accurate research synthesis on cutting-edge topics in computational linguistics and natural language processing. Subscribe to our YouTube channel for weekly research syntheses covering the latest developments in AI, machine learning, and computational linguistics. Our content provides comprehensive analysis of emerging trends and breakthrough papers, making complex technical concepts accessible to researchers, practitioners, and AI enthusiasts alike. Join our growing community to stay informed about the rapidly evolving landscape of artificial intelligence and its applications. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from arXiv preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer. This video uses arXiv.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv.org.